Students, we'll start with the next topic, that is the uses of convex mirrors. Okay, now these convex mirrors are commonly used as a rear view mirror in vehicles. Okay, now these mirrors are fitted on the sides of the vehicle so that the driver is able to see the traffic behind them, okay, to indicate the safe driving. Now convex mirrors are preferred because they give an erect though diminished image. If we recollect, okay, yesterday we have seen two images formed by convex mirror. Okay, now if you see at infinity, you get a very diminished image here, and if you see beyond pole, anywhere on the principal axis, you get a image smaller than the object. Okay, but both these images are virtual and erect. Okay, so if we come back, the convex mirror enables a driver to view the larger area. Okay, the mirror is small, but the area which is viewed in the mirror, if you see, a large area is covered in that mirror. Okay, and the images which are seen are diminished. Okay, so large area is covered even though the images are diminished. Okay, so in your question answer section there is one question: why do we prefer a convex mirror as a rear view mirror of the vehicles? Okay, now the next topic is sign convection for reflection by spherical mirrors. Okay, now here, okay, this is a 5 marker question. Okay, the diagram for this is given on this next page, figure 10.9. Okay, so along with that you have to study this and draw this diagram. Okay, and then write the points. Okay, so I'll be teaching you both simultaneously with the diagram. Okay, so keep the textbook with you. Now here, the first thing is, in this convection, the pole of the mirror, okay, is taken as the origin. Now this point, this topic has to be deal with the graphs. Okay, you have to recollect the graphs which you have already studied. Okay, the principal axis of the mirror is taken as the x-axis, that is the x dash x coordinate of the graph. Okay, so if you remember the graphs, okay, here you have got the x-axis. Okay, now this x-axis you have got x and x dash here. Okay, this is the x quadrant, x-axis. Okay, fine. Now according to this, the object is always placed to the left of the mirror. So if you can see the mirror here, the object is towards the left of the, this is the object, it's towards the left of the mirror. Okay, fine. Now the light of the object falls from the mirror from the left hand side. Okay, so the light is falling like this. Okay, now we go to the second point. All the distance parallel to the principal axis are measured from the pole of the mirror. So anything which we want to measure, it starts from the pole. So if you want to go this side, you have to go from here. You have to go this side, you have to go from here. Okay, fine. Now the third point is, all the distance measured towards the right side of the origin are positive and towards the left are negative. Okay, so whenever, if I want to measure the object distance, the object is placed here, so I have to measure from here to here. So we are going towards the left. So whenever we are going towards the left, all the distances will be negative. If you are going towards the right, all the distances will be positive. Okay, and the distance is measured perpendicular to the principal and above are positive, while the distances perpendicular to and below are negative. So this distance, that is above the principal axis, all these distances are positive, all these distances are negative. Okay, so these are certain points which, all these points you have to write if this question is asked, and you have to draw this diagram as it is given in your textbook. The labeling should be done in exactly the same way. Okay, now before, I'll just tell you some additional points, okay, to remember, for especially for the sums or the illustrations which we'll be doing. Okay, now the object distance, okay, that is PB. Can you see this? Okay, this is always negative and it is denoted by U. The image distance, can you see this PB dash? Okay, now this is denoted by V Now for real images, the images which are formed on this side, it will be always negative, but the images which are formed on this side, okay, it will be positive. So image distance depends on the type of the mirror, because if you see in the previous cases, here the images are formed here, so they will be positive. Okay, similarly for this mirror also, this will be positive, the image distance. Okay, fine. Now the last small topic left out, okay, in continuation, is magnification. Now magnification is the ratio of the height of the image to the height of the object. Okay, and it is represented by letter M. Okay, so M is equal to h dash upon h, where h dash is the height of the image and h is the height of the object. Okay, so this is the formula of magnification. Now this magnification also can be given by another formula according to object distance and image distance, that is v upon u, that is image distance upon object distance. Okay, now there's one important thing to be remembered, that the height of the object is always taken as positive. Okay, because it is placed above the principal axis usually, so this is always positive, right? Okay, while the height of the image depends. For virtual image it will be always above, for real it will be below. So here for virtual it will be negative, and for for virtual it will be positive, and for real it will be negative. Okay, now whenever your magnification, okay, if it is positive, okay, negative sign of magnification indicates real image and positive sign indicates virtual image. Why? Because see, magnification is v upon u or h dash upon h. So if one is negative, that means the it's a real image, and if it is positive, it is virtual image, because for virtual image both will be positive, image also and object also. Okay, for real this will be negative and this will be positive, so here you will have negative sign for real images. Okay, thank you.